Angel, I am so sorry I forgot to record up until now. But here it is. You can pause it. And here's everything that we've seen. Bet. All right. So here we are. As we're trying to make this decision, Sean, how many choices do I have for cos 2x? I have 3 of them. Now, I'm going to let somebody pick this, and you should not write out all 3 of them, but I'm going to, because I think and I hope that we might be able to find the one that works. I'm just going to use colors. We'll call this one green. I could conceivably replace this cosine of 2x with 2 cos squared x minus 1 plus cos x. And that would still all be equal to 0. That's an option. Okay, give me another option. Bea, I haven't called on you directly. Sorry, Barcega. Instead of replacing this with 2 cos squared minus 1, what could I replace it with? Love it. So maybe we replace this with 1 minus, now the parentheses aren't going to do anything, so I'm just going to drop them. 1 minus 2 sine squared theta plus cosine, and I'm going to call it x, plus cosine x equals 0. And Mickey, third option? Yeah. Love it. Now, as we're going a couple things, all 3 of these are completely fine. Remember that if you're just reading stuff to me, if you write it down without the argument, like in an actual problem, I'll burn you. But if you just read this as cos squared minus sine squared, I'll take it. Like, you're good in just speaking language. And there would still be this plus cosine. Okay. Now, any 3 of these will take us down the path, but we always want the most efficient, the easiest. Talk with your neighbors. Find me the issues with the one that doesn't work. Something that makes a problem just significantly worse. I'm going to give us 20 seconds, and then calculator's coming in. All right, so the question becomes, why do we hate it? Number 11, as long as it's not Angel. Who's 11? Sean. Is it? Kalisha? All right, Kalisha, why do we hate it? You get the choice, whether you're 11 or not. Which one do you hate and why? So we're mixing cos squared and sine squared and cosine? I agree, I hate it. Get it out of there, it's garbage. It's not really garbage, but for this problem it doesn't work. Fern, we haven't made eye contact until just now. Which one do you hate? Why? Golly, I don't want to mix sine squareds and cosines, that's awful. What do we love about the green one? It's cosine and it's easier, at least. It's definitely easier. I'm looking for what I was expecting was cosine x and cosine squared x, which is just like having a u and a u squared. This is like a quadratic. Okay, so what's our favorite F word? Factor is the correct choice. So looking at this, I need to know how would we step on number 10. We're going to start with this green option, and I just need to know where do I go from here? Rearrange it. How would you like me to rearrange it? Love it. I would do the exact same thing. Now, this is a throwback. If you need to write stuff down, you can. This looks scary. It's not scary. I have the same thing, that cosine x, in 2 different places. If you want to, you can, but I will never give you credit if you're not clear with the math. I could use a substitution in place of these. Instead of cosine x, what do you guys want me to write? What do we use as our substitution with quadratic types? Louder? U. If you want, you can let u equal cosine x. Now, in doing so, how would we rewrite this first term? It would be 2, what? U squared plus, what's u, minus 1. This looks scary. This does not. They're the same thing. We're just hiding the variables to make it look a little bit nicer. At this point, we are in factor land, which is awesome. Number Riley, I need to run through my factoring, which means, you know, I'm up here and it's super embarrassing, but I've completely forgotten how to factor, which is strange. It happens so frequently. What would you do to start? So, awesome. You jumped right to trinomial, which makes me think in your head you already went through, it's not a binomial, and you've gone through that. There's no GCF, I think. So, it is a trinomial, I agree. What are our methods for factoring trinomials? Okay, so you're telling me to do this. Okay, this is grouping, is what we're going to attempt. I multiply the leading coefficient 2 and this one, we get negative 2. I need factors of negative 2 that do what?
Add up to 1.
Can you tell me factors of negative 2 that add up to a positive 1? 2 and negative 1 will do the trick, right? They add up to a positive. Cool. Now, in this, because the way it's written, there's this one little weird part that I'm just going to deal with. I want to rewrite this u, and I'm going to color code these just so we can hit this again some more. This u is going to get replaced using these. So we're just going to take this 3-nomial, and we're going to rewrite it into a 4-nomial so we can factor it, and we can group it. So let's do it to it. If I rewrite this thing, 2u squared, should have kept the color, plus 2u minus u minus 1. Okay, apparently I have a lot of alarm bells ringing all the time. There's something that I'm concerned about happening incorrectly in this particular setup. I imagine I've harped on it all year long. Something about the negative. So what do you want me to do? Can you be that a little louder? Okay, so I'm going to put the groups on, and then, because I get the feeling that you're talking about the same thing. This changed it. So what do I need to add? Plus, right? Unintentional, but love it. I make sure that we add the negative to make sure that we're not magically changing. Okay. Issue, Sean. Agreed. What do 2 and 1 multiply to be? Okay, cool. Good call. Always call me out. Appreciate it. Okay. JV, what's the biggest thing that you can take out of this front group? 2u. Hate it. Don't know what I picked. It's awful. 2u, though. Sounds good. Kalisha, what else could I take out of here? Or what would it leave behind if I took out a 2u, rather? So there's a 1. What if we took 2u out of 2u squared? So we already have the 2 and the u. Because it's like I took out the 2 and I took out one of these 2u's. Cool. All right. Now, factoring is always good as long as I can make the groups match. Charles, to leave behind a u plus 1, what should I take out? Love it. Negative 1. And it's u plus 1. Okay. Weirdest part, but this is what we've seen all year long. Abigail, can you tell me 2 factors from this expression? And I'm going to do one more thing. What would u represent this whole time? So I'm just going to replace it. 2 cosine of x minus 1 is one of my factors. That's this one. What's the other factor, Mickey? Instead of u, what am I going to replace it with? Love it. Cosine x plus 1. Okay. Awesome. We're done, right? No, it would be a shame if we stopped here and did all this work to not get any credit because we didn't finish the problem. I know that those 2 things multiply to be 0, yeah? Okay, so I'm going to give you a second. I want you to do it independently. I'm going to give you a head start and I'll do it on the board. I want you to find me the roots between 0 and 2 pi of this equation. Cool. No plus n pi's or anything like that. Just get me my solutions. There's no tangents and there's no.
I'll fill it in.
There's another one missing.
Yeah, the identities, the ones.
I'm trying to remember which one.
I can't remember the name.
Some difference.
Yeah,
Thank you.
some-
All right. Looking at this, everybody, do me a favor. From your perspective, point me to any place where cosine is positive 1/2. About right there. Okay. The x is smaller than the y. What angle is this in radians? Pi thirds. I love it. Okay, so check it out. Pi thirds is one of them. Where's the other? So that's in quadrant 1. Which other quadrant is cosine positive? So pi thirds is up here. And then it's negative over here at 2 pi thirds. It's negative down here at 4 pi thirds. 5 pi thirds. Because we're jumping, and if you, we'll look at that here in a second. You said 2 pi thirds, right? Okay, but if we're at pi thirds here, sorry, here, and then if we go 2 pi thirds, we're here. 3 pi thirds gets us to pi. So then 4 pi thirds, and the next one would be, yep. Cool. So only these two places, plus 2n pi, if we were working, you know, in the infinite interval. Where's cosine negative 1? Sean claims pi. Anybody agree with that?
Yeah.
Love it. We have them. Okay. These problems, pretty much the same thing is going to shake out on each of them. Now, I'm going to leave a little bit of student voice and choice in this matter here for just a second. There are other places and other bigger things that we could get. In fact, infinitely many things. I'm going to leave a challenge that entirely up to you, but I would leave a little space. You will benefit. As a different example, I want you to try to derive the sine of 3 theta. So we have double angles. Maybe, just maybe, we could find a triple angle. We're not going to do this right now. If you can explain it to me at the start of class tomorrow, I got you with a homework pass. You have to be able to explain it. Walk me through the whole problem. Cool. To be more specific, tomorrow before school, if you stop by and walk me through this whole problem, I will give you a homework pass. Sweet. All right. So we can evaluate, we can solve. Let's do one more like this, and then I have a different type of example, and it looks like we'll have 10 minutes to work on stuff. Cool. Before moving on, questions, issues, things you hate, didn't quite get, and now that we're done, you want to ask? Does it feel doable? Prove it. Okay, on B. You guys get the privilege of solving the following. I want to know, when is it true that 3 sine squared of phi plus cosine of 2 phi minus 2 is equal to 0? Cool. 3 sine squared phi plus cos 2 phi minus 2. Sweet. I'm going to pause it here. Angel, if you're watching this, go ahead and do the same. You will see a detailed solution in 3, 2, 1. Once we have these wonderful parentheses, I'm just going to look and recognize as some like terms. 3 sine squared phi minus 2 sine squared phi is just 1, right? Sine squared phi. And then what's the constant that we have? Minus 1 equals 0. Okay. At this point, it's easy sailing, I hope. If we want to solve for this, what do we do? So that question seems hard, but here's the analogous. If you want to solve this one, what would you do? They're the same thing. It's just the way that we write it. So let's add 1. And I don't remember what color it was. But that says that sine squared phi is equal to 1. Now that's all fine and dandy, but are you guys super comfortable in thinking about sine squareds? Probably less so than just sine. Can we make it so it's just sine? How? Let's take the square root of both sides. Okay, so that would tell me the sine of phi is equal to, what's the square root of 1? Okay, big, good. Big thing. I've made a terrible mistake. Oh my, plus or minus. You take the square root of a number, we add in the principal and the negative. Are there places on the unit circle where sine of phi is positive 1? Point to it. Straight up. What's that radian? Pi halves. So check it out. There's one of our answers. Phi could be pi halves. Where's the place that is negative 1? 3 pi halves, and we done. Okay. These problems. Question. Love it. Can I look at your work? And follow up, would you bring it up here? And do you mind if I just put your work up on the screen? If you don't want me to. Love it, love it, love it. Okay, so we're going to compare and contrast. Here's the way that I think about this problem. Is that the only way to think about the problem? No. I've said it before. I legitimately think all of you are better at math than I am. I just happen to know more math than you do right now. So, like, subtle difference. Let's dig into Rafa's. So it looks like this one. Is that true? No, it's probably that one. Okay, so let's check it out. Rafa changed to 1 minus sine squared. Love it. Okay, here and here is where Rafa and our paths kind of diverged a little bit, I think. What did Rafa do between this third line and this fourth line? Yeah, I know that 1 minus cosine squared can replace this sine squared, which when we do this, I would be very, very careful, Rafa. I think you kind of lucked into the answer, possibly. Because when you do sine squared as 1 minus cos squared, the 1's fall out, and this should be cosine squared. Because it was equal to 1 or negative 1, you wound up lucky there. Everything else other than that square works out perfectly. This method just as valid. Cool. Nice work. All right. Thank you. Cool. So there are some alternatives to what we can look at. I want to have you have weird. I want you guys to do a few problems for me. And this is going to be your homework, the start of it at least. We get 13 minutes in class so that if there's issues and questions you can ask before. I'll tell you, tomorrow I will take this and I will just do the second half and we'll finish it and we'll leave ourselves in a wonderful situation. Absolutely. We're going to leave ourselves in a nice situation to take the quiz or team test or test. We'll talk as a class on Wednesday, which means it leaves you 5 days to either study for a test or 5 days to not think about anything related to math except for that which we do with pleasure all the time anyway. Okay, so here we go. I already have it written down. I'll come back to this, Huggins. I got you. I will be right back, but I'm pretty sure I already put the homework here. Kapah. Okay, homework 5.5.1. Problems 1, 2, and 7 through 21 odd. You can skip 13. Now, there is one problem in here that I really want us to highlight. And I do this intentionally. It might seem like a jerk thing to do, but that's okay. We're all fine with it, right? Cool. So, we've talked about it before. We're in here for 50 minutes a day, every day. Like, that's a lot of time. But do we have enough time to do every single type of problem? No. Now, there is one particular problem on here, I believe, that you have not really dealt with yet. Looking at number 21, and I'll just throw it up here on the book real quick without just giving you the answers. They give me U's and V's and stuff looking at this. So they say, hey, here's a sign of U, and here's a value. If I have to make sense of this problem, there are examples in your text, but could you draw a triangle? Possibly. If I tell you that sine of U is this. And then from that triangle, if we know that the sine of U is here, you could probably go twice as far. I want you to try this problem. This is similar to the compositions that we did where we had two angles, U and V. I want you to try this. Don't spend a crazy amount of time on it. Like, don't go past the time limit that we have. But I do want you to try this without us going over a problem of this type, because you have all the tools, you have the ability, you just need the perseverance, which I think you all have too. Cool. All right. DJ Holloway coming at you live. Let's go ahead, spend some little time, get started. We did not work a brain break in there.